Hello again, Kevin Culp here from Supermicro. Thanks for sticking with me as we build out our KVM hypervisor deployment for your business enterprise. Now I've configured my business enterprise environment, you might ask yourself, how do I support it? What tools do I have that I can save time and maximize my efficiency to support this infrastructure? How do I troubleshoot an outage? How can I tell my Ethernet switch is performing well? Well, as an administrator, those are all the right questions to ask. As I mentioned in previous videos, the goal of SuperCloud Composer is to support your infrastructure. That means compute, storage, and networking. Today, all of these are offered in the public cloud. Why do we see cloud repatriation? The big ones are cost, compliance and governance. Administrators want to be in control of their own destiny. Open standards using Redfish. Our mission with SuperCloud Composer is very simple. Provide administrators the ability to streamline their tasks into one unified dashboard to support their infrastructure requirements. As I mentioned before, don't be fooled to think that SuperCloud Composer is just another cloud product. People's definition of cloud varies. SCC is a tool to streamline your enterprise, supporting day 0 to day 2 activity. Break down those challenges that exist in the infrastructure by providing our customers a unified dashboard experience without having to go to disparate tools, gather that data, thus delaying their data-driven decisions. So let's jump into the last video and take on the role as a troubleshooter. So now we built out the KVM hypervisor infrastructure. So how do we troubleshoot it, right? So I've actually logged into a PuTTY session here for my KVM hypervisor, and then I also have a window here where SCC is here. So what we've done here in this video podcast is bring in all these various different technologies and collectively working in conjunction with basically switch lifecycle management. So we showed you the power of provisioning those VLANs, looking at various different things, and being able to support the infrastructure requirements that you need to build out your enterprise for business applications. So the first thing I want to do is let's go ahead and look at the switch itself. So we're going to look at the MAC address table and determine specifically here what particular MAC addresses are showing up in the MAC address table. So I have a cheat list here that I've actually compiled. And what I've done here in the background is I've actually started doing ping sprays to all of my KVM hypervisors to basically force the MAC address table to basically learn, both from the actual bridge that exists on the KVM hypervisor and the ones that are the MAC addresses that are in our switch, which is our Arista Switch that we're using for compute. So let's start with basically MAC address in VLAN 100. So we're going to pull up the VLAN 100 and then we're going to do a refresh here and we're going to see some MAC addresses that are showing up here. So first thing is let's really think about this for a moment, right? So we have our Ethernet 11 connection where is our uplink port into our KVM hypervisor. So this is where we've created on our switch a .1Q trunk presenting those VLANs, VLAN 100, VLAN 200, VLAN 300, and VLAN 672. Remember, 672 was used for the management interface. So right away, we've popped in here MAC addresses, which are virtual machines. How can I tell this? Is because really the type of style of MAC address is showing. It's a generated MAC address. If you're running a VMware environment, it would be running 0050 as the first. So when you look at a MAC address, the first thing we need to really define is how do those MAC addresses, or what do they mean? What exactly is it? Well, the first 3 octets, which are 52, 54, and 00, represent what we call the OUI. That is the OUI identifier, or the organization in which they've come from. right? So these are predefined MAC addresses that have been registered in IEEE standards. The last two represent the serial number of basically that system, right? So this is how we generate MAC addresses, and we have them registered so we don't have vendors out there stepping on other vendors' MAC addresses. They're already registered in a pool through IEEE. So these are basically generated to CentOS that they can basically use. In the CentOS community, whether you're using RHEL, whether you're using VMware, whether you're using Microsoft, right? So the 5254 is the first clue to say, that's a MAC address, which is a virtual machine. So now what we're going to do is we see, okay, so our KVM hypervisor is populating our upstream switch for those MAC addresses. So that's a good thing, right? Because if those MAC addresses weren't populated up into the switch, how could they forward packets to other particular VLANs and act as an L3 router, right? So those are important, right, to understand the concepts of specifically layer 2. So now let's go over to the hypervisor and actually issue a command here, bridge control showmax BR1. So that's basically the bridge. And you can see here that the bridge associated with the Linux host is basically actually forwarding those or basically learning those MAC addresses from the VM. So remember that the VNIC is hooked into the V port of basically the bridge, and so we're seeing this information. So if you think about this and try to get your head around this, so when I was actually starting out and trying to understand conceptually what's going on here, all a physical switch is a Linux-based kernel that's been actually implemented on that switch. We call it a network operating system, and it uses the same concept of Linux-based stuff, of packet forwarding, like we basically do on a software CentOS implementation. So it's just a software implementation of basically the bridge itself. So the first thing I want to look at is this D8-3A. Usually look at the 2 octets because those ones basically change. Sometimes it'll go to the third one that basically changes. These remain stationary depending on if you're changing the vendor itself. So I always kind of just look at the last 2 octets because it's easy to remember, right? And a lot of times they won't be duplicated, right? Sometimes they will, but for the most part, they are pretty static. So look at D8-3A, and let's go over to this environment and see, okay, so I'm seeing D8-3A showing up on my Bridge 100 interface. So immediately it should give you a clue. Okay, my Bridge 100 interface is my subnet associated with 100. So which particular VM is that associated with in the bridge table? And that happens to be really our CentOS 1 system. How do I know this? Because I've actually looked it up, and we can go over to the CentOS machine and quite honestly look at it and determine it is definitely by doing an IP adder show, looking at the MAC address and seeing that it will be D8-3A, taking that, mapping it back into, start with your bridge on the hypervisor first, see if it's being connected, and see it's being learned on the bridge. If it's not being learned on the bridge of your hypervisor, then there's a couple of things that you can think about troubleshooting. Maybe the hook, the electrical hook there of connecting your VNIC to your V port is not connected or hinged to the right bridge, right? So you can go back into your virtual machine manager that I showed you and make sure that NIC is connected to the right bridge. And we showed you that based on going onto the light bulb there and being able to determine that, right? So those are simple troubleshooting things that you can do to determine if it's working properly. Now the other thing is that when let's say that your MAC address is showing up in the Bridge 100 table and you see it there, but yet we don't see it on the MAC address in the upstream switch, then that means that there could be an issue here. Maybe you're not physically connected to the right port. Maybe you're not configured for .1Q trunking. Maybe you don't have your bridge configured correctly. There could be a lot of things that the upstream switch is not seeing or learning, specifically your MAC address table. So I'm trying to provide you with a correlation here of how you would take VLANs from a switch and be able to troubleshoot it associated with the bridge that exists on the KVM hypervisor. So let's look at another one. So this other one here is D0C1. We also see it in the bridge table, right? So what is D0C1? So D0C1 is another system that is one that we just added, which is CentOS 3. So when we provisioned the new and instantiated the new particular system, when I showed you in the previous video, that particular system has now been configured for an IP address, and it also is living in bridge 100. Remember, we selected bridge 100 for that one, and then we're able to see that that's showing up in our MAC address table, and then also in the MAC address of our particular switch. So let's look at another one. So we've looked at bridge 100. So let me clear that gobbledygook out, and then we'll go ahead and put in bridge control 200 itself. And incidentally, the bridge control feature is when you deploy a group installation for KVM hypervisor, it is not a YUM utility that automatically gets downloaded. So the YUM utility is a separate utility called bridge control or bridge dash utils. So when you go out and build your KVM hypervisor, make sure you have the tools there to help you basically troubleshoot. And so you can issue a YUM install of the bridge dash utils command or utility, and that will provide you with the bridge control, all of the bridge control functionality from the command set you can do here. So if you look at bridge control, there's all kinds of things that basically you can go ahead and mess with, like things like STP, spanning tree off, bridge priority, everything that you would functionally do on a physical switch or bridge is available within the soft bridge, right, under CentOS, RHEL, that kind of thing. So let's clear out the gobbledygook again here, and let's go ahead and look at 200. So 200 is the other bridge we configured for other VMs to hinge to. So now what we want to do here is we want to look at bridge 200 and VLAN 200, excuse me, and we see MAC addresses showing up now in VLAN 200. So the first thing we see is, do we see C068? Yes, we do. We see C068, excuse me, over on the bridge, which is in the hypervisor. So again, we're seeing those MAC addresses being forwarded up to the upstream switch through Ethernet 11, which is basically that .1Q trunk that we configured. So we presented multiple VLANs to that particular .1Q trunk on Ethernet 11. So let's look at okay, so let's look at another one here. 42FD, it's showing up here too as well. Again, same thing, same pattern. So you need to understand which particular bridge you're looking at to be able to look at the MAC addresses and see if those particular MAC addresses are being learned up onto the upstream switch. So if they're not being learned, then the ping is going to fail, right? Because there's going to be no interconnectivity there that's going to exist, right? So understanding and being able to map the MAC address from physical switch to soft switch on the hypervisor is going to be a very great tool for you, and is an important asset for you to be able to troubleshoot network outages. All right, so let's look at the last one, which is bridge 300. Let's clear the gobbledygook again, and then let's look at 300. And when we look at 300, let's go and look at the MAC address here at 300 itself, and then do a refresh command, and immediately we see 96OF here, and then also just one that we show up, 96OF. Some of these other ones we could basically trace to as well that are showing up here. So you're seeing 2586, likely probably the station MAC of our upstream Tor switch that we're connected to. We'd have to go in and take a look at that. So let's look at that. So 2586. So if we go back to our physical assets here, so I'm curious, let's see if we can trace down 2586. So if we go to maybe perhaps it is an LLDP neighbor we have upstream to us, right? So let's see. Let's look at the Arista here for a moment and see who our LLDP neighbors are on 45. There it is, right? So we have who our upstream switch is, right? So although we have it populated in the KVM hypervisor itself, we now have determined who even our upstream switches by being able to look at basically 25886, which is a station address, going over and basically looking and seeing here on 45 where we had the table was populated to indicate it was 45 that we're using because our MAC address table showed us that, and then we went over quickly and looked at the LLDP neighbor that we had. We're showing that on 45 our upstream switch is basically L3 Tor switch that's connected into our corporate network. So very easily to decipher a topology map in your head by looking at various different things, looking at tools within SuperCloud Composer, compiling those tools with other tools, and be able to quickly make those data-driven decisions to minimize that or mitigate that downtime or network outage for you so you can bring those systems up as quickly as possible. All right, I'm going to show you one other thing before I let you go, and thanks for hanging in here with me. So the next one we're going to do is look at essentially our performance collection that we're using for switches. And so we're going to go to the monitoring details section here, and we're going to plug in and find out the 172.24.199.45, which is the Arista switch. Again, SuperCloud Composer uses both sonic switch integration, our super micro switches, and third-party switches. Why do we do switch integration for third-party? Because we work with those particular customers that provide us a RESTful type of API that we can go and integrate. Again, it's about not having disparate tools to be able to manage your particular infrastructure, right? It's important to have all of this here, be able to troubleshoot. So look at 199.45 here. So we're going to look at essentially port 11. So let's see if we can make this a little bit larger so we can override what we currently have so you can see what we're having. And let's choose 11 because that's our .1Q trunk. I believe we have some information there that we can take a look at. And so let's look at 11. And you can see here now we've generated port counter traffic here that has been, looks like it's been peaking upwards. So some of the pings that I've been doing have created this particular traffic. You can see here we did some work on previous videos showing you various activity based on our pings and things like that, and I initiated the ping here about 9:25 this morning, and we're generating basically traffic. So this is easy to show you information from the standpoint of collecting those port counter information. Again, not having to go to the switch to get that information. It's all contained in a unified dashboard. Easy, streamlined to make those data-driven decisions very quickly instead of having all those disparate tools to be able to collect all that data and then try to make those data-driven decisions. So that's our vision here, providing that unified dashboard experience for you. All right, so we're going to do one other thing here. I don't think we have any unicast traffic, but let's see what we got here. So we want to look at essentially Ethernet 11. I don't think we're generating any, but we can always go check anyways. Maybe 0, but let's see what we see here. Okay, where's 11? I've got to talk to my developers to fix this because we really need to start at position number 1 and sequentially go down. So a little bit of an improvement here on our user experience here for finding the right interface. So no unicast traffic, but if we were generating any kind of unicast, broadcast, multicast type traffic, we would certainly be reflecting it in our counter information here and showing you as the port rate. So that completes the entire podcast for third-party switch integration, building out your KVM hypervisor infrastructure. Thanks for joining. I bid you a good day here, and we'll be back bringing up new videos to give you some better insight on what SuperCloud Composer's value proposition is to your enterprise, your business enterprise, and your infrastructure. Thanks again for joining. We'll see you next time.